Hi everybody, today we are going to learn about section 4.5, linear inequalities. This is page 8 in our notes. Okay, we're going to determine which of the following points A, B, and C, are solutions to the linear inequality y is less than or equal to negative x plus 3. Okay, so I set up some templates so I can plug in my coordinates. On this first one, I want to check to see if 1 is in fact less than or equal to negative 0 plus 3. That would give me 1 is less than 3, and that is true. So A is definitely a solution. I'm just going to put a check mark next to it. Next, I'm going to plug in 3, 2. So my 2 is going to go in for my y, my 3 for my x. So I have 2, is that less than or equal to negative 3 plus 3? Well, negative 3 plus 3 is 0. 2 is not less than 0, so I'm just going to kind of put an x. B is not a solution. Then next, I'm going to plug in 3, 0, so 0 for my y, 3 for my x, and then I would get 0. Is that less than or equal to negative 3 plus 3? That's 0 again. And that's just barely true. 0 is actually equal to 0. Since I have this line underneath, this is in fact true. So A and C are solutions, B is not. Finish writing that down, please. Okay, I have a graph of the line y equals negative x plus 3 drawn right here. And I have A, B, and C, points A, B, and C from over here on my graph. And you can see that A is on the lower side of the line, B is on the upper side of the line, and C is actually on the line. Well, it turns out there are an infinite number of solutions to a linear inequality. And if one point on a side of a line is a solution to the inequality, then every single other point on that side of the line, on that same side of the line, is also a solution. So since we know A is a solution to this inequality, every single point over here is a solution. So what would that tell us about this point? 1, negative 1, is it a solution? Well, of course it is, because it's on the same side of this line as A. And there's an infinite number of points on this side of the line. So what we do is we actually shade the side of the line that are the solutions to the inequality. So I would make my graph look like that. All of these are shaded because all of these points, if I plug any of them into this inequality, they are solutions to that inequality. All right, sometimes we'll see linear inequalities that are strictly less than, like this. In that case, we make a dashed line. You say dashed, or you write dashed like that. And like we just saw in the previous example, sometimes we have less than or equal to, and that's when we make a solid line. All right, for an example, we're going to graph the linear inequality y is greater than 1/2 x minus 1. So I'm going to start here at negative 1, and I'm going to move up 1, right 2, up 1, right 2. And I need to make either a dashed line or a solid line. You probably guessed that since we have y is strictly greater than, we're going to make a solid line like this. And now I need to figure out where I'm going to shade. I always like to pick the point 0, 0 if possible. And I'm going to check this point. If this point is a solution, then all of the points are solutions. If it's not a solution, then none of the points are solutions. So I'm going to plug in 0, 0 to this. Is 0 greater than 1/2 times 0 minus 1? And you can see I picked 0, 0 because it's easy to do the calculation. Is 0 greater than negative 1? Yes, that is true. So since this point is above the line, I'm going to shade right here above the line. All right, let's do this example where we have an equation that is in standard form. So this is supposed to say 6, not 0. So we are going to use the x and the y intercepts to help us graph this. So I'm going to do 6 divided by 2, and that's 3. So my x-intercept will be 3, 0. 6 divided by 3 is 2, so my y-intercept will be 0, 2. And now I can use this symbol to determine to draw a solid or a dashed line. You guessed it, we're going to draw a solid line. And now I'm going to use the point 0, 0 to determine if I shade below the line or above the line. All right, you should have plugged in 0, 0 and got that 2 times 0 plus 3 times 0 is 0. That is less than 6. That is true. So I'm going to shade below the line in this case. So my graph will look like this. All right, that's it. They're pretty easy to graph.